Well, good afternoon, everyone. I'm Ryan Siegel. I'm joined today by my colleague, Sean Maurer. I want to thank everyone for joining us today on our webinar, touching on commercial lighting requirements. We'll also have a few power requirements, as that also is in the same section of the Energy Code. Specifically, we're focused on the 2021 International Energy Conservation Code. The state of Illinois will be transitioning soon to the 2021 IECC from the 2018 IECC. That is slated to occur sometime this summer. So for permit applications filed beginning perhaps mid to late this summer, that will be based on, you'll need to be basing those designs on the 2021 IECC. So want to make sure everyone is perhaps prepared for that transition and begin to get your designs up into the new generation. So we are going to be providing certificates of completion for all participants who are on today's webinar. We also do have continuing education credits specifically for ICC, AIA, and BPI. So for those of you, as you registered, you may have been asked for your AIA or ICC member information, if that was applicable. If you do need BPI continuing education credits, when you receive that certificate of completion, please reply back to that and let us know your necessary BPI member information so that we can get those filed for you as well. So I believe today's webinar is one of the first ones that we are offering the BPI at as well. So I want to see if that is in fact useful to people. So we are going to be looking at several of the changes moving from the 2018 IECC up to the 2021 IECC. Along with that, we're also going to be looking at some of the Illinois Energy Conservation Code updates, particularly for plant lighting. Also wanting to make sure that we are do allow you to comply with the commercial lighting provisions and understanding some of those impacts for it. A little bit of background about who we are. CDAC, the Smart Energy Design Assistance Center, is housed at the University of Illinois here at Urbana-Champaign. Our primary mission is to reduce the energy footprint of the state of Illinois and beyond. So our code training is one of the methods that we do that, along with many other programs that we have here. So obviously, part of this is education. We also do some research and hands-on information and data gathering, along with advocating for our greener future across the state of Illinois. So we have been watching the and participating in the updates of the 2021 Energy Code and the upcoming soon to be developed 2024 Stretch Energy Code for the state of Illinois. So I do like to thank our sponsor, State Energy Office, through the Illinois Environmental Protection Agency, is sponsoring today's training. So we do like to thank them for that. And we are the state's Energy Code training provider. As part of our program, we do offer technical support assistance through our email address, energycode@illinois.edu. So if you do have code questions about the state's energy code, particular situation that you're running into, does this comply? Does it not comply? How do I make this comply? Things like that, or design review where, hey, I had this submitted for plan review. Does this kind of fit with the state energy code or not? Feel free to reach out to us. This is available for any projects here in the state of Illinois. So that could be building owners, occupants, code officials, design teams, contractors, etc. So do also have several online resources on our website, smartenergy.illinois.edu/energy-code. Along with that, we also do have archive versions along with upcoming workshops and webinars and several online on-demand training modules. Each of these take somewhere around an hour to an hour and a half to complete. They are available with a little bit more of an introductory audience in mind. So, mention that we are coming up to the 2021 IECC transition here in the state of Illinois. The city of Chicago went ahead and they have adopted 2021 IECC along with some amendments. So the Chicago Energy Transformation Code is already in effect. And again, the state of Illinois, for all other jurisdictions, is planned to transition here sometime this summer. Our website will include links to the 2021 IECC along with the Illinois amendments when they become available for that. So I want to make sure everyone is aware of that. Here's a brief look at several of the different things we do have on our Energy Code website. I had mentioned some of our past and upcoming workshops and webinars, several online courses in our technical support. This is also where we link back to several different useful things, such as the Chicago Energy Transformation Code along with the Illinois Energy Code. We do have several frequently asked questions on our website. Those will also be updated for the 2021 IECC coming up. We also do have checklists. So some of these also include things such as templates for the building certificates that are now required for both residential and will be required for commercial buildings as we move to the 2021, along with several energy code smart tips. So things like piping insulation, domestic hot water systems, and things like that. So we do here we do have some links to the different codes. Again, these are also available on our website. So rather than trying to necessarily remember all the big long string, you can come over to our website and we can connect you up with that. This is part of a series. We do have a couple of workshops. One that occurred previously on the importance of mechanical insulation. Those archives are on our website, noted here under our events. We also have an upcoming in-person presentation at the DuPage County Auditorium. So as kind of noted today, we're covering 10 items that are specifically dealing with lighting. This top 40 is going to deal with everything from residential, commercial envelope, commercial HVAC, and commercial lighting. So for those of you who may be interested in an in-person experience, that will be coming up in June. So please go ahead and do get registered for that if you are so interested. You kind of may have observed we had broken that 40 into 4 groups of 10. So each of these 10 are going to be about a 1-hour session. Had residential and commercial envelope in the past. Those are archives and video recordings are available off of our website. You can also find us on YouTube. And the commercial lighting we're going to cover today, upcoming next month, is going to be commercial HVAC systems. So with that, here's a brief look at what we're going to be looking at today. Some of the efficiency requirements for dwelling units, occupant sensors and various controls requirements, lighting power allowances, plant growth, and the like. Before we dive into that, we do want to launch a poll here and get people's familiarity with and understand, what do you struggle most with? Is it the lighting power density requirements, occupant sensors and their requirements, time switch controls, daylight harvesting controls, or other. If you do select other, go ahead and put that answer into the chat as well, so we have a good understanding and make sure that we cover that as we go through today. Give that another second here. I'd mentioned that our presentation today will cover lighting, as we will also touch on a couple of power things since it is in the same section. So that'll include automatic receptacle controls and energy monitoring that will be coming soon. Looks like just about everyone's gotten answered in. So go ahead and end that poll. Okay, looks like first is daylight harvesting controls, followed by lighting power density controls. Then you get into time switches and occupant sensors. So we'll definitely try to make sure that we focus in on those as we're going along on our presentation. So with that, I'm going to turn it over to Sean to take it away, beginning with our dwelling unit efficiency or efficacy.
All right, thank you, Ryan. Before we jump into that, we did have a request to go back to our resources slide. So if you get to our energy code page on our website, one of the links is to the checklist we've developed. So you can find those checklists there. So on to our dwelling unit requirements. So this is a new one for the 2021 IECC. It states that in commercial buildings that have primarily permanent occupancy dwelling units, not less than 90% of the permanently installed fixtures shall have high efficacy lamps. Don't confuse this with the residential building provision. The residential provision, 100% of the permanently installed lighting has to be high efficacy. So a commercial building that has residential occupancies in it, those occupancies need to have 90% of the permanently installed fixtures at 90% of high efficacy fixtures. So don't confuse the two. Be sure to keep those straight. We want to kind of stress that here for you. Moving into occupant sensor controls, there are some new requirements here, some more stringent updates, and really a lot of clarification of the original code text. Some of these sections were kind of paragraph form. They've broken them out into bullet pointed sections. So they're a little clearer to understand to help with enforcement of the code. For occupancy sensors, where those are required, not a whole lot of changes here, except that corridors have been added to the list. So corridor lighting will now require occupant sensor controls. We'll get into the specific details. There's a specific section that deals with how corridor lighting should be controlled by occupancy sensors. All these other sections were already there in the 2018 IECC, so no changes as far as additional spaces there. But there has been some clarifying language in some of these specific areas. One of those is for warehouses. Similar to 2018 IECC, aisleways have to have separate occupancy sensor controls in each aisleway so that when an aisleway is not occupied, the lighting in that area can dim down. 50% within 20 minutes of that aisleway being unoccupied. Previously in the 2018 IECC, that was 30 minutes. So they've tightened that unoccupancy window down a little bit. They have stressed that those aisleways and open areas outside the aisleways have to be controlled independently. Lights that are not turned off by occupancy sensors, such as in the open area, should be turned off by a time switch control, complying with the time switch section of the code. And manual controls must be provided so the occupants can manually turn lights off and on as they need. So the last two bullet points here were kind of understood from the occupant sensing control requirements, but they've specifically added those into the warehousing section here so that you know that compliance needs to be met. It isn't kind of left vague anymore. For open plan offices, not a whole lot of changes here. They've done some rearranging of where requirements are located. Control zones are still limited to 600 square feet for an open plan office. Lighting in those areas, once the zone's unoccupied for 20 minutes, the lighting has to turn down to 20% or completely off in those zones. Once all those control zones are unoccupied, then the lighting should turn fully off. What's been added here is that automatic full-on control is permitted within individual 600 square foot control zones. And then the other unoccupied control zones can turn on to 20% lighting power or remain off. So that's been added into this section here. There was a bullet point about daylighting controls and how the occupancy control should not be overridden by the daylighting controls. That's been moved to the daylighting section. Kind of makes sense that the daylighting control should be in the daylighting section. So the requirement is still there. It hasn't been removed. It's just moved to another section of the energy code. There is an exception to point number 3, the turning off general lighting in all zones within 20 minutes. If space general lighting is controlled by a time clock, then that is handled by the time clock instead of an occupancy sensor control in the open plan office space. So this is just kind of further clarifying that dimming is an option in these unoccupied zones and turning the lights on to a dimmer setting so that the offices, even if the individual control zone isn't occupied, some of the lighting is on for future occupants as they walk into the space. It's not completely dark for them. As long as somebody has entered in one of the open plan office areas and is occupying that space. For corridors, occupant sensor controls, this is a whole new section that's been added in. But unoccupied corridors must reduce lighting power by at least 50% in a reasonably uniform pattern within 20 minutes after the space is unoccupied. If your corridors are already dimly lit, you've got that 2-foot candle or less lighting intensity at the darkest point in your hallway with all the lights already on, then this occupant sensor control doesn't need to be complied with. But if you're brightly lighting your hallways, then this occupancy sensor control does need to be complied with. Some places we've already seen something similar to this kind of control. Hospitals that are trying to match circadian rhythms for occupants and attendants and stuff have already had kind of this kind of occupant sensor control in place. And we've seen it applied in other areas. So now it's just expanding that and making it a requirement for energy code compliance. For all other areas, again, this is generally unchanged for the code now from the 2018. Spaces must turn off lighting within 20 minutes of occupants leaving. Manual on switching is required, but it can be auto on if the lighting power is limited to 50% or less of full power. And you do have to incorporate a manual control so that occupants can turn the lights off if they need to in that space. Nothing worse than going into an occupied area, the lights are on, there's a sensor controlling the lights and you can't turn them off if you need to do a presentation or something like that. So you do have to have that manual control. The exception to this has been modified a little bit. They've added in that full auto on with no manual control is permitted in corridors, restrooms, and other areas where manual operation would endanger occupant safety or security. So you don't want to have a corridor where the occupant sensors turn the lights off, someone's walking in and the lights don't turn on and they have to do it with a manual switch. So you're allowed to have that full auto on. You don't have to have that manual switch in that corridor or one of these other areas. So they've kind of clarified that text there. You don't have to have that manual control for these specific areas where safety is a concern. For light reduction controls, where you don't have occupancy sensors, you're using a time switch or manual control. you have to have light reduction controls in those spaces. So they've added a couple more exceptions to this section and a little more clarification on application. So manual control to uniformly reduce lighting by at least 50%. And to align with ASHRAE 90.1's requirements, you now have to have an intermediate step somewhere between 70 and 30% power or continuous dimming control for those spaces. Again, you can dim all the lamps' luminaries. You can switch off individual light fixtures or individual lamps as long as it's a uniform dimming of that space. But they have added in that 70 to 30% power step in there or continuous dimming that brings the IECC into alignment with ASHRAE 90.1. The exceptions here are unchanged from the 2018 IECC. Spaces with daylight responsive controls or special application controls of the lighting do not have to have these light reduction controls. And manually controlled spaces with limited wattage or safety concerns, specifically listed here, corridors, lobbies, electrical and mechanical rooms. Those spaces are not required to have the light reduction controls in them. Daylight responsive controls, we've expanded some of our requirements here and added some clarifications in the 2021 IECC. But similarly to the 2018 IECC, if any of you are familiar with our presentations from the last few program years, we like to start off with this exception. If your connected lighting power is less than an adjusted lighting power budget, you don't have to install these daylight harvesting controls. You can simplify your building's control plan, eliminate some sensors, save some costs for your client. The way that works is if your normal lighting power budget is less than a weighted average of the area of your daylit zones times 40%, subtracted off from your normal lighting power budget, then you're below that threshold and you don't have to install these daylight harvesting controls. So just a couple examples of how that calculation looks to try to help clarify this point. In a 200,000 square foot office, if 100,000 square foot of that is in a daylit zone, 40% of that 100,000 is 40,000 square feet. Subtract that off of the 200,000 square foot area. Calculate your lighting power densities. So the way this works is if your lighting power density is 0.79 watts per square foot, your lighting power allowance is 158,000 watts. If you take off that 40% of that 100,000 square foot daylit zone, that reduces your lighting power wattage to 126,400 watts. So if you can hit that target, that's 20% less than your original allowance, then you don't have to have the daylighting sensors. If your daylighting zones are a little bit smaller, so now we're looking at 50,000 square foot. If you take the 40% of that area and apply it to your lighting power wattage, now it's only a 10% reduction in your lighting power allowance. So 142,000 watts.
Before we dive too far into the actual requirements, let's take a moment to check some learning. Got another poll question here.
Mm-hmm. The poll.
All right. Oops. So wanting to look at relaunch. All right. What percentage of lights must be high efficacy in a dwelling? So is this 100%, 90%, or does it depend on if this is a commercial or residential building? And the second one is if one installs occupancy sensors in a space where they're not required, are time switch controls also required? Yes or no? As Sean pointed out, with these daylight controls, we definitely encourage people to use that exception because that definitely simplifies your building and also simplifies the commissioning of it later on.
We did have a note struggling kind of work out which requirements to apply to which different space types. The occupant sensor controls has that list of specific space types that those sensors apply to. So those get occupancy sensor controls. If you don't have a space requirement listed there for occupant sensor controls, then you do the time switch controls. With time switch controls, or add an occupant sensor control. With the time switch controls, then you have to have also the ability to reduce the lighting power. Okay, looks like most of our poll responses are in.
All right. Looks like most everyone picked up on, yes, it depends on, is this residential or commercial building? If it is a residential building, then the number is 100%. If it's a commercial building, it has to be at least 90%. So that is something, it does depend. Previously, in the 2018 code, the commercial requirement just pointed to the residential, but for 2021, they removed that point and actually specified it directly. So that is a change coming up. In question 2, if one installs occupant sensors in a space where they're not required, are time switch controls also required? Most people did pick up that no, if you do occupant sensor controls, then you do not have to have the time switch controls for spaces. This trade only goes one direction. So the code does allow you to install occupancy sensors in lieu of time switch controls, but if it's called out as a space that requires occupant sensor controls, then you are not able to put the time switch controls in lieu of those occupant sensor controls. So
I'll turn it over to Ryan to go through a little more detail on the daylighting controls in the next few sections.
All right. So daylight controls, this is where if you don't take advantage of that exception, then you got to know where the triggers are. So first, this was another substantial change. That is something that people will perhaps pick up on, is many of the changes moving from the 2018 to the 2021 IECC are more closely aligning the IECC with ASHRAE 90.1. So several of these requirements that you're seeing today, as far as they're new to the 2021 IECC, these are requirements that have already been in ASHRAE 90.1. So for daylight controls, first understanding, have we met the threshold? So first, do we have at least 150 watts of general lighting? So this does not include your task lights. So this is your general lighting load, at least 150 watts, which, understanding a lot of fixtures nowadays are, 25 watts. That's what, 6 fixtures in the daylit zone. So the primary side lit zone, at least 150 watts there. That's one threshold. The next threshold is, do we have at least 300 watts of general lighting in the primary and secondary zone? So because we have the secondary zone is a roughly equal area to the primary zone, we have double the area and double the wattage of that. Or do we have 150 watts of general lighting in a top lit zone? So if any of these 3 triggers are met, then you have to have daylight harvesting controls, unless you use that exception. So there are a few spaces that they specifically exempt in this. And so one of them, obviously, healthcare facilities where patient care is directly provided. That would not necessarily mean it applies to the entire healthcare facility, but only those spaces where the patient care is directly provided. So that's something to be aware of. And then do have some specific application controls called out for in a later section, C405.2.4. So that is where you'll have specific applications. That is commonly things such as display lighting and things like that, where it may be on a different schedule than your general facility lighting. So Also, for first floor applications in Group A2. So this is typically food and beverage establishments, as well as Group M mercantile occupancies. So this is where, kind of your front showcase or storefront. You're gonna have a side lit zone there. So they do have some exceptions in there for these particular occupancies. So let's talk about what the side lit and top lit zones. This is a very helpful thing. Is the International Code Council does make all of their codes available for viewable for free on their website, and they even include these helpful diagrams. So what we see here is for a side lit zone. So this is obviously adjacent to vertical fenestration. In order to qualify, that fenestration area has to be at least 24 square feet. So if I have a smaller window, the code is kind of calling out that if it's a smaller window, it's not letting in enough light to really make an impact and allow for appropriate daylight harvesting controls. Actually did work on a early lead project where they had put in fairly small fenestration, and they did add daylight harvesting controls, but they were never really able to work right because there wasn't enough daylight coming into the building. So also it specifies the visible transmittance of at least 20%, of at least 0.2 or 20%. If you have severely tinted windows, again, I'm not having enough lighting coming in order to achieve that. So with the code, it also calls out, this is some other changes that they've made for this year. Again, first is the primary, and then we have a secondary side lit zone. So the first primary side lit zone is the height of the fenestration flopped in. So they did tweak on this a bit. It used to be the full head height flopped in. Now it's just the height of the fenestration flopped into the space. And then the secondary side lit zone is another 1 times that height. So this 2x, 2 times the height is your primary and secondary lit zone. So, also going from side to side, this was another change. It used to be just 2 foot on either side of the window. Now it is 1/2 the height of the window. So if we have, a fairly tall window and a fairly narrow window, this side lit zone could be rather wide. Again, because of that height ratio. So it also does talk about for this is getting into top lit zones on the right side here. We see some rooftop monitors and showing how that side lit zone is calculated, being the height of the opening away from it, along with a quarter of that height on each side. Also, if you do have obstructions that are more than 70% of that ceiling height, those are considered partitions and not allowing that daylight to spill over into that area. So something to be aware of. These can get kind of difficult. We do recommend that designers do either shade these or put a dashed line around them, kind of like they have on these diagrams where they're kind of shading, here is the area covered by this daylit zone. Again, going back to that, you have to know what 40% of that lighting allowance for that particular area is. So it's extremely helpful if somewhere on the prints, particularly if that one with the dashed line or the shaded area, go ahead and call out what that square footage is, because that makes it a lot easier later. So Other top-lit zones is commonly skylights. So these, obviously, a roof monitor is pushing light only in one direction. Skylights is able to push it in multiple directions. So here you're getting, instead of that half the height on each side and then 1 times the height forward, this is 0.7 or 70% of the height in all directions here. So it does call out a few things. So for top-lit zones, understanding, do you have any, if you have some tall buildings beside you that are blocking that direct sunlight from hitting the fenestration, then that may be excluded. Also, if you do have, again, either tinted or fairly small openings, those will be excluded from this area too. So the code does call out in several buildings, this is more in the envelope area that they call it out, buildings that require skylights. So being aware that there is an intersection between this lighting requirement and the building envelope provisions. So for those of you that may have missed the envelope webinar, recommend go back and check that out. So another new diagram that the IECC has come out with is for atrium areas. Previously, these were kind of left out. They just assumed that people would be able to figure out what to do with those. They've now added one for atriums and understanding, and you see in this picture, they are different in whether it's a rooftop monitor that's used for the atrium or if you use a skylight for the atrium. How you calculate that changes depending on what you're using for that. So a definite dramatic improvement in some of these, but that can also make things a little more difficult. So exterior lighting controls, they did make a little bit of a minor change to this, along with some clarification. For those of you who may have seen some of our past presentations on this, this will look very familiar to you. So decorative lighting, this is also more commonly known as facade or landscape lighting, has one set of provisions, and then other general exterior lighting has a separate set of provisions. So daylight shutoff is required for both regardless. And then you have time switch control that's required for both regardless. The only provisions that are different between the two is decorative lighting has one set of requirements for setback, and then if it's non-decorative lighting, that has a slightly different set of provisions for it. So there's pretty much the three types. Everything needs daylight shutoff and time switch function, and then your setback is just your other one to determine. So for general lighting, got our daylight shutoff, and then if it's facade and landscape lighting, we need to turn those off within 1 hour of the business closing and not turning them back on until within 1 hour of the business opening. So those are going to have to be turned off. Whereas if you're not dealing in facade and landscape lighting, so all our other exterior lighting needs to have setback. So we need to reduce that wattage by at least 50%. That is up from 30% previously. So we've got to drop at least 50% of the watts, either by switching or dimming. Either one is available. And in one of the 3 times. So either you have to set it back either from midnight to not earlier than 6 a.m. or similarly that 1 hour of business closing to 1 hour of opening. If you do choose that one, that does make time switches a little easier since it's going to match with your facade and landscape lighting on the same schedule. The third option is for where any time activity has not been detected for at least 15 minutes. So this is occupant sensing, occupant-based controls. So another new requirement is if you have luminaires that are at least 78 watts and mounting height of no greater than 24 feet above ground, then you need to do occupant sensing controls on those. It's kind of where they've technology is grown to the point looking at it and saying there's enough wattage to capture, and the sensors are economical enough at that lower mounting height for that. So time switch controls. So again, we've got to have daylight shut off and time switch controls. The reason for having both, particularly as we've moved to LEDs, is these are more expensive and heat during the middle of the day is the most damaging to them. So we want to make sure that they do turn off. So in case that daylight sensor fails, the time switch is going to be a good backup for you too. Another new section for the code is parking garages. So here, kind of similar to our understanding of parking garages. Oftentimes, several of these are a little bit more open to the environment. And so if you're within 20 feet of the perimeter wall and the walls are at least 50% openings, then we need to do some daylight responsive controls for those areas. And we also need to do occupant sensing controls to reduce lighting power by at least 30% within 20 minutes of inactivity. So they also do have this minimum threshold of at least 1.5 foot candles on the floor at the darkest point. So if you have very low light levels already, presumably fairly energy efficient, low energy, then you don't have to do the occupant sensing. So by designing low energy spaces, that's a good way to take care of that for you. So also, as you're near the entrance of the parking garage, they do have provisions for eye adaptation zones to be controlled separately for that. So fortunately, a lot of manufacturers are building more and more of this technology already by default into their products. So with that, let's do another poll just to check some of our understanding here. What is the wattage threshold for daylighting controls? Is it 150 watts in the primary zone, 300 watts in the primary and secondary zone, or no requirement if your power density is low enough? You may choose one or more of those options. And second question, are occupant sensors required for all exterior lighting? Go ahead and give that another second or two. All right. Let's see here. Let's see here. Do you have a question here regarding that daylit zone and the width of it? That again is kind of called out. So where those that daylight is, that whole width, it will depend. So if you do have a building that the entire side is 3 foot tall and the entire side of it is glazing, then your daylit zone is going to be that 3 foot coming in the entire width, or that entire width of the building. So you're likely to hit that daylight responsive controls requirement Again, that's a big reason why we kind of keep hitting on that. Use that exception for you. So as far as our poll questions, the wattage threshold for daylight controls, 150 watts in the primary zone. Yes. 300 in the primary and secondary zone. Yes. And there is no requirement if you get your lighting power density low enough. Yes. All three of these are correct. And for our second question, are occupant sensors required for all exterior lighting? That would be no. Only those that have a high enough wattage threshold and a low mounting height is for that. And with that, turn it over to Sean to talk about our lighting power density and other requirements.
All right, thank you, Ryan. So lighting power allowances, we've seen a little bit more stringency coming in here. One of those is in calculating your total connected interior lighting power. Most of this is the same. You're going to count up your lamp wattage by the line voltage for the lamps or the label on the fixture, the ballast and transformer input wattage, your LED driver input wattage. Those are all unchanged, similar to what they have been. Track lighting has been updated. It's your connected wattage, your transformer wattage, or 8 watts per square foot, whichever is greater. That 8 watts per square foot has been reduced from 30 watts, or not square foot, per foot of track length, has been reduced from 30 watts per foot of track length. The big reason for that is LED technology. They don't pull a lot of wattage. If you're trying to cram in 30 watts of LEDs on a track bar, you're going to have a lot of lighting power there. It's going to be pretty bright. So ASHRAE 90.1 does still have 30 watts per square foot. The National Electric Code still has 150 watts every 2 foot of track length. So they're still working off of the old CFL or halogen track lighting. With LEDs, though, the IECC is taking that into account and reduced that to 8 watts per foot of track length. Looking at our interior lighting power allowances, there's 2 different methods, just as it has been for a while now. You got the building area method where you've got a building type, you apply a lighting wattage power density across that whole building area type. Or for a little bit more flexibility, you've got the space by space method where you take tables of lighting power densities for individual room types and usage types and apply those across the individual space types in the facility. So what we're looking at here, if it's colored red, there's been a little bit of relaxation in the lighting power density requirement. If it's in green, then it's been tightened up. So you can see here, automotive facilities, libraries, workshops, slight increases in those. But on the whole, lighting power densities are being reduced. Again, we're accounting for much higher efficiency lighting fixtures with LED technologies and things like that. And so overall lighting power densities are being decreased. Something to look at here, the Performing Arts Center is the highest space category on the table at 1.18 watts per square foot. One load that we've covered that's not a Performing Arts Center is meeting that allowance is theater lighting. So theater lighting is going to have a little bit higher lighting power density allowance there for the stage lighting. Again, that lighting hasn't necessarily caught up with LED technology yet. We're still using halogen lamps there to get that lighting case in place. And so Performing Arts Center is talking about the lighting out off the stage in common spaces for that center. Looking at exterior lighting power allowances, most of these are generally unchanged from the 2018 IECC. Haven't seen too many updates here. According to U.S. Office of Management and Budget, there are 383 metropolitan statistical areas. So as you're looking at this list, Zone 4 is that metropolitan statistical area that, high intensity lighting usage area. In Illinois, Chicago, Main Street there is probably the only area where Zone 4 is going to apply. Zone 1 is probably state parks, natural areas, places where you're not going to want a whole lot of lighting. You're trying to limit night sky lighting. Most of your projects for exterior lighting are going to be in Zone 2 or Zone 3. Zone 2 is that mixed commercial and residential areas, and Zone 3 is going to be exclusively commercial areas. So as you're looking through your projects, grand majority of the time, Zone 2 and Zone 3 requirements are going to apply. Lighting for plant growth is a new requirement added into the IECC for this code cycle, and there is an Illinois amendment proposed that could affect this. Lighting for plant growth, all permanently installed luminaires shall have a photon efficiency of not less than 1.7 micromoles per joule for greenhouses and 2.2 micromoles per joule for indoor growing spaces. There are exceptions for buildings with no more than 40 kilowatts of aggregate plant lighting and cannabis facilities. There's already in Illinois a requirement for lighting power density in those areas for plant growth. And so there's an Illinois exception that applies to that. This is also a little bit more stringent than what's in the IECC. So the Illinois amendments propose more stringent lighting efficiency, pretty much requiring LED plant growth lighting for grow spaces. Moving on into power requirements. So previously the IECC just had the lighting requirements and didn't touch on receptacle controls and power requirements too much. To align with ASHRAE 90.1 again, we're starting to see those being adopted into the IECC. So here, automatic receptacle controls have been added in, at least 50% of the receptacles in all enclosed offices, conference rooms, and rooms used primarily for print and copy functions, break rooms, classrooms, and individual workstations need to have automatic receptacle controls applied to them. At least 25% of branch circuit feeders installed for modular furniture, not shown on the construction documents, also needs to have automatic receptacle control. And this can be done on a time of day basis, based on an occupant sensor, based on a control signal. We've seen something along the lines of for individual workstations, if the computer monitors go to sleep, that power drop for the computer going into sleep mode triggers turning off lighting and other plug-in functions for miscellaneous add-ins at that workstation. So there's different technologies that can apply here. It's one of the big dramatic differences between the 2018 IECC and ASHRAE 90.1 that's been resolved with this code cycle. Buildings have been able to address in a dramatic fashion the envelope, HVAC, and lighting loads with the IECC. Now it's bringing in these plug loads as well, because those are becoming a larger portion of the overall building energy consumption as we're getting more and more efficient with our building envelopes, HVAC systems, and lighting. Plug loads are growing in proportion of their energy use. And so implementing these controls is targeting that growing power sector for building consumption. As far as triggering the controls, a little bit more detail. Could be using a time clock where those turn off at the end of the business day. A little bit of wiggle room there for people that might stay late working. Occupant sensing controls, you can tie into lighting sensors in the space to turn off peripheral equipment, things like that. And as we touched on, badging systems can also trigger these systems as well. So as long as there's some kind of control function that's indicating the occupancy in the space, that technology can be used to automate these receptacles. Energy monitoring is also a new requirement in the 2021 IECC. Big thing that we're trying to target here is tracking where energy is being used in buildings. So measurement devices should be installed on buildings greater than 25,000 square feet or more and monitor the use for HVAC systems, interior lighting, exterior lighting, receptacle circuits, since those are now under control, large process loads, and then building operations and miscellaneous power. What we're trying to target here is through monitoring of these systems, you can identify when an issue has come up. You can link this to your building automation system and link it to an alarm feature that indicates my time clock's not working properly. My light stayed on all night when they should have set back at midnight or something like that. HVAC system's not working properly. Its energy consumption's gone up from what it was the previous month or the previous year. And so the more we're automating our buildings, what we're noting is that it's hard to keep track of the energy consumption of all these things to identify when there are issues early and address them before they start costing us a significant amount of energy. By adding in these monitoring systems, now we're also adding in the ability to track that consumption over time for individual components of the building so that troubleshooting is a little bit easier. For buildings with 408 volt service, there is an allowance for 120 or 208 volt HVAC systems to be included on one of the other categories, probably receptacles or building operations. So small window units, things like that, don't have to be tied into an HVAC system, monitoring system. They can be on a miscellaneous or plug load monitoring. So that brings us to our last poll question. Where are automatic receptacle controls required? Hotel rooms, classrooms, commercial kitchens, enclosed offices, convention centers. There are multiple correct answers here, so pick the ones you believe are correct. And what loads are required to be monitored? Again, multiple correct answers. Receptacles, total building, vehicle, electric vehicle chargers, and facade lighting.
I imagine the automatic receptacle control will be quite contentious as people try to implement that. Part of this is going to be, communicating to occupants that plug loads are becoming a larger load, and secondly is, in what are certain loads that, in case you forgot to unplug them or turn them off, what do you want the building to remember to turn off for you? And I think, Sean, your badge system example is a great control integration strategy where for buildings that do have people badge in and badge out, you badge in and the building says, oop, they're going to they're coming into the building. Go ahead and activate all their receptacles for the day. And at the end of the day, as they badge out, which actually is good practice to have people badge in and badge out, such that the building's like, okay, they're done for the day. I can turn it off for them.
And something else to be aware of is those receptacle controls, key pieces of equipment aren't controlled by those. It's usually ancillary equipment. Like, some people use their computers remotely from home. The receptacle is not turning off the computer itself. It's allowing that to use its sleep function, but it will turn off the monitors, the printer that's hooked up to it, things like that aren't as important. And so communicating that with occupants will help alleviate some of those concerns as well.
Let them know to not plug the computer into the controlled receptacle unless they want it controlled.
All right, looks like most of our answers have come in for our poll. Share those results. So for question 1, automatic receptacle controls, looks like all of these are correct except for the commercial kitchens. You do not want receptacle controls in there.
Nope, it's only 2. Classrooms and offices.
Nope.
The only 2 on the list.
Okay, yep.
Yes, hotel rooms have, commercial kitchens, and convention centers are not on that list of automatic receptacle control requirements.
And then loads required to be monitored. Receptacles are. Total building isn't included on that list. You get that with your utility bill, so you don't need a separate monitoring system for that. Electric vehicle chargers were not on that list. Facade lighting is. It's part of the lighting set. Okay. Don't see any questions come in. So I want to thank everyone for joining us today. If you do have any follow-up questions or things you want to reach out to us about, contact us at energycode@illinois.edu. We'll be happy to answer your questions there. Thank you all for joining us for the webinar today. We hope you have a wonderful afternoon.